Hello, this is a brief example for the Simpson scientific method assignment that you need to complete on Canvas. So with this assignment, what you need to do is to read the various experiments that are being performed by the Simpsons characters and determine the components of that experiment, namely the independent variable, the dependent variables, the constants, and the controls. So you need to be able to pick out these ideas out of experiments because you will see this on your next unit test, which, by the way, is coming up next Friday, August 28th. And then also you will need to be able to do this on the EOC. Let's take a look at an example of what you're going to be doing in this assignment. So Grandpa Simpson thinks his neighbor at the retirement home is too loud. He decides it would be a good idea to soundproof his room. Grandpa believes that walnut shells filling the space between the walls will block out the sound, but his friend Jasper thinks that cotton balls will work better. Using a sound meter that Professor Frink built for him, Grandpa and Jasper perform an experiment. Okay, so we have a scenario here, we have a problem, we have a noisy neighbor, and we have an idea of how we want to solve this problem. So using the scientific method, how would we go about doing this? Step 1 of the scientific method, we have a problem, so we've defined the problem. Step 2, do some research. So maybe Grandpa hasn't done enough research, but he moves forward anyways. So step 3 is to develop your hypothesis. So a reasonable hypothesis that you might have here is that if the walls are filled with walnut shells, then the volume of the sound will be reduced because the walnut shells will absorb the sound. A good hypothesis is written with an if, then, because statement. The if gives us what you need to do. The then is a statement of what you think will be the results. And then the because is your reasoning behind that. So here, Grandpa is saying, if I fill the walls, okay, that's what he's going to do, then the volume will be reduced. That's what I think is going to happen. And then the because, this is going to be your reasoning behind it. Now, is this great reasoning? And we'll find out. So now that we have a hypothesis, we can then start defining the components of our experiment. So first off, we need to ask ourselves, what is the control of this experiment? Remember, your control is the standard for comparison. So here, we're going to compare our results with the wall with no filling. So we're simply going to measure the sound coming through the wall. So let's say that Grandpa, since he's living at a retirement home, his neighbor is old and can't hear very well, so he cranks up the TV. So he's watching Price is Right in the middle of the day. So what we need to do is we need to get a measurement of the sound coming through the walls as it normally is. So what is the noise that is bothering Grandpa? Once we have that measurement, we can then use that as a means of comparing. So once we fill the wall with some sort of soundproofing, whether it be walnuts or cotton balls, we can then compare the measurements from that to the wall with nothing, and then we can see, does it make a difference? Next, we need to ask ourselves, what's our independent variable? Remember, the independent variable is the manipulated variable. This is the thing that we're changing from one experiment to the next. So here, our independent variable is the different fillings, so the walnut shells versus the cotton balls. Next, we need to ask ourselves, what is the dependent variable? Remember, dependent variable is also called the responding variable. So this is the factor that we're measuring. So what are we measuring in this experiment? We're going to be measuring the volume of the noise coming through the wall. The scientific unit of measuring volume, measuring the loudness of a sound, is called decibels. Finally, for this experiment, we need to think about what are all the constants. What things need to stay the same between each test? So first of all, we want to make sure that we're using the same wall. Sounds kind of weird, but if you fill one wall with walnut shells and a different wall with cotton balls, you could have two different types of sounds coming through different walls, so that's going to throw off your results. We also want to make sure that we're using the same sound meter, because a homemade sound meter might work well enough for an experiment, but you might get different results if you used like some sort of fancy professionally built sound meter. If you want to be really accurate, you'd probably want to make sure that you have fresh batteries in the sound meter every time you do a test, because you wouldn't want something like low batteries to affect your results. Other factors that you might want to keep in mind and keep constant is the kind of sound coming through the walls. So if Grandpa's neighbor is listening to the TV too loud, then we want to make sure that we're taking our tests when he's watching TV. Because if we do one test while he's watching TV and then do one test when he's like running a vacuum cleaner, you're going to get very different kinds of results. Other things you might want to think about when designing an experiment as a constant is things like time of day. People don't often think about this, but sound actually travels differently during the day than it does at night. If you've ever been outside at night and realized that you can hear things that you don't normally hear during the day, that's because sound actually travels farther at night. The air density changes at night, so sound travels differently. So even considering what time of day are we doing our experiment could have an impact on your results. There are some other constants we can probably think about, but again, anything that you would keep the same from one test to another would be a constant. So here are Grandpa's results. So he measures the wall with the walnut shells, the wall with the cotton balls, and then the walls that are empty as your control. And Grandpa, being a good scientist, runs multiple trials. He does several tests because the more data you have, the more reliable your results are. So with the walnut shells, he gets a measurement of 12 decibels, 24 decibels, 18 decibels, and 21 decibels for an average of 18.75 decibels. With the cotton balls, he gets 28 decibels, 4 decibels, 20 decibels, 28 decibels for an average of 20 decibels. And for his control, he gets a measurement of 56 decibels, 49 decibels, 54 decibels, and 61 decibels for an average of 55 decibels. To give you some context, 55 decibels is about the volume of normal conversation. So if you're standing in a room talking to somebody, your voice is probably going to be somewhere between 40 to 60 decibels. I'm talking to you right now, depending on how you have the volume set on your iPad, probably at around 50 decibels. Looking at these results, you might say that, walnut shells are the better soundproofer because the measurement of walnut shells was lower than the measurement of cotton balls. Something you might want to consider is that when you look at those two measurements, the difference is only about 1.25 decibels. And humans really can't hear the difference between 1 or 2 decibels difference in sound level. So you have to ask yourselves, is this a significant difference, a significant change between each other? So when choosing a material to fill your walls with, if you're going to soundproof this way, you would want to consider which one is more effective, but you might also consider what's more cost effective, what's cheaper in price. It might be really expensive to get a bunch of walnut shells. It may be cheaper to get cotton balls. So with these results, you might ask yourself, well, cotton balls are not as good, but we can afford more cotton balls than we can walnut shells. Now, looking at this data, you might ask yourself, there's something that stands out, something that just doesn't quite fit with the rest of the data. And that's right here. In test 2 with the cotton balls, we have a measurement of 4 decibels. This is way off of all the measurements that we got elsewhere in this experiment. And to give you some context, 4 decibels is about the sound that a mouse would make walking across the floor. Needless to say, it would be very, very quiet. So maybe something went wrong with this measurement here. Maybe Grandpa's neighbor left the room and we didn't realize it and took our measurements anyways, so there wasn't really any sound coming through the door. Something like this is what a scientist would call anomalous data, meaning that this is data that doesn't fit the rest of our measurements. What we have to do is we have to ask ourselves, what are we going to do with this data? One thing we can do is possibly just eliminate that data. Something must have gone wrong with this part of the experiment. This is what a scientist would call a source of error. Something outside of the control of our experiment affected our results. So it would be okay to eliminate this data, but there's something we have to consider. We can't just eliminate one piece of data. If we wanted to eliminate this 4 decibel measurement, we'd have to eliminate everything from test 2. We would have to assume that test 2 was somehow in error, so we're going to just throw out those results. Now, there are some consequences here because other scientists could look at this test and say, well, you had to throw this out. This draws into question the validity of your entire experiment if something this big happened. But if we can safely say, okay, there was something went wrong, so we're going to eliminate this data, we would then have to go back and recalculate our averages. So if we do that, we end up with these results. So with the walnut shells, we get an average of 17 decibels. With the cotton balls, we get an average of 25.3 decibels. And their control gives us 57 decibels, pretty close to what we had originally. Here, we see a much more significant difference. The difference between 17 decibels and 25 decibels is something definitely that a human can detect the difference between. So here, the walnut shell seems to be the better insulating material, the better soundproofing material. So we would conclude here that this evidence supports Grandpa's hypothesis. Now that we've gone through this example, you should be able to successfully complete the Simpson scientific method activity. This is going to be due next Tuesday, so please make sure that you're working on this. And if you have any questions, please let me know.